Alright, ladies and gents, buckle your seatbelts. We're going to talk about U substitution. Alright, so we're getting into the kind of the meat of doing what for us at least this year will be fairly difficult integration problems. Alright, so we're going to talk about problems in which we are trying to basically reverse the chain rule. So if we think about the chain rule itself, it looked like this. Alright, so the derivative with respect to x of f of g of x is equal to f prime of g of x times g prime of x. So we know that integration is just the reverse or the inverse of taking the derivative. So if I could get a function to look like this, where I had the indefinite integral of f prime of g of x times g prime of x dx, then I know that the antiderivative of this would just be f of g of x, and then the indefinite integral, we get the constant of integration plus c. Alright, so this is one of those things, like many things in life, it is true, but not particularly helpful. At least not at first glance the way it's written here. So what we'd like to do is we'd like to take a look at this part of it and see if there's a way that we could maybe write that in a more simple form so that we can actually make good use of it. And then we're going to do that with what's called U substitution, sometimes just called by substitution. And we're going to make that g of x, that function of x, we're just going to call it u. So you can see right away how if we do that, if we define u as g of x, and then we take the differential of u, it's g prime of x times dx. So that takes care of this part for us. So we have u du. So that allows us to simplify this a lot and write this as the antiderivative or the indefinite integral of f prime of u du. Right? So in general, we're going to let u equal the inner part of any composite function. So we're going to look for these three things. Quantities, any quantity raised to a power, that's a good candidate for u. The arguments of any trig functions, that's a good candidate for u. And then trig functions whose derivatives are the other trig functions in the integrand. We'll see some of these. Those are also good candidates for u. So we'll move on to page 2, and really we're just gonna work through several examples in these notes. So stand by.